Hey, David. Good morning.
Good morning, sir. How are you?
I'm good. Thanks for joining.
Yep.
Let's give it a little bit of time, maybe a couple of minutes.
I hope so. Otherwise, it'll just be a one-on-one conversation.
Exactly.
Hi, everyone.
Hey, good morning, Kate.
Good morning.
Good morning. Good morning.
I think we can just get started. I don't know if we're gonna get a lot more audience, but the meeting is actually recorded.
Yep, that's perfectly okay. Just want me to start then?
Yep.
All right, excellent. Let me find the right share. So I'm going to talk about two projects that we've put up for sandbox proposals. One we call Turnbuckle, one we call Pallet. Again, neither married to the names nor the icon, because you'll find out we're engineers, not graphic artists. So we lack in icon building skills. Anyway, Turnbuckle is a project we started with, and what we looked at is how can we start expressing constraints across workloads. If we look at the constraint model in Kubernetes today, a lot of the constraints are things like CPU, memory, really focused on a given workload. As a networking company, we think about connectivity. And so we thought, how can we start looking at constraints between workloads, such as simple constraints? I want a latency constraint between pod A and service B of 10 milliseconds or a jitter of 5 milliseconds. How can that be expressed, and then how can that be incorporated when we do scheduling? And that's where Turnbuckle really came to be. And so we created a constraint model where you come up with a constraint policy, which is in turn a set of rules. And I'll go over that in a little more detail later. And then the constraint policy, off the constraint policy, we create what we call a constraint policy offer. And that offer essentially uses label selection to map a constraint policy to one or more resources, being just label selection. Then as the policies or the offers are evaluated, they in turn create constraint policy bindings. And essentially, these are realizations of a constraint policy offer bound to a given set of endpoints or a given set of resources. And so those are kind of the real things that are happening. And those are then associated and evaluated in terms of are the constraints being met? Are they not being met? Are they violation, limit, capability? One of the things we wanted to do as we developed this was make sure that the service or the constraint model was extensible without having to recompile the code. And so the policy rules, which are part of the constraint policy, are essentially a way to look up services. So we thought, okay, how do we make this extensible? Service model in Kubernetes. And so what we'll see as we look at a service definition, essentially using labels to locate a service to evaluate a policy rule. And this means that anybody can add policy rules just by adding a new service and then using labels selection to map a rule to a service for evaluation. This has some drawbacks and benefits, to be quite honest, right? The drawbacks, of course, we're doing a lot of RPCs. The benefits is, of course, we are completely extensible without having to modify source code. It also has a benefit, which I think is a benefit, is there are no built-in constraint policies to this model. Everything's created the same way, right? I talked about latency and jitter as things that we cared about initially as kind of a test case. But they're not built into the system. It can be used for things like security, anything that you can think of in terms of constraint models. It can also be used to specify single pod constraints or single workload constraints as well. There's nothing in the system that says it has to be bound to inter workload constraints. Today, we haven't extended it to multi-cluster. We had plans to, because when you talk about networking within a cluster, if the cluster is at a given data center, all connected via LAN, chances are that you're going to have pretty good network connectivity within that data center. So when we looked at this, kind of the initial implementation was an interesting implementation, and we learned a lot. But we thought as we expand this out to multi-cluster, that's where some real benefits going to be. Additionally, what we saw is we wanted to be able to affect the underlay network. And what we did for that is in earlier implementations, and we haven't put this in this project yet just because we're kind of working through it slowly and cleaning code up as we go, is what we call the network controller. And this, the idea behind a network controller, and I'll talk a little bit more detail about later though, is that during scheduling or during what we call remediation, when a constraint has been violated, we can reach out to the network via the network controller to perhaps correct the issue using a network controller. So we call it a network controller. It really is a remediation controller because it doesn't necessarily have to deal with networking. Additionally, we integrated with the projects, deschedule project, as well as the projects for scheduling, the scheduler plugin, and we'll talk a little bit more about that. And that's kind of Turnbuckle. Before I go to Pallet, are there any questions about that?
Yeah, I have questions. So does this work only on CNF Fabric, or does it work on not? Okay, so would it work with something like the AWS CNI or Calico or Flannel or any other network overlays in Kubernetes?
Right. Again, because we haven't built in any telemetry or specific constraint policies, you could build a constraint policy that takes into account whatever you want. So for instance, we didn't want to build in, oh, how do we do data collection across the network, right? We built some samples, and in the source code, you know, we have some of those, but we didn't want to bind it to any given management system for telemetry collection. So really, this is just a framework to define constraint policies. If you wanted to realize a constraint policy, such as latency or telemetry or security, you would have to implement those rules. And in terms of the project, we'd be more than acceptable to have kind of a contrib area, if you will, where people could put different policy rules, because that makes sense, right? We expect people to add new policy rules based on their needs. So you could absolutely build a policy rule that collects telemetry or uses telemetry from AWS or Google or Azure and uses that information for the scheduling. The system itself calls out through well-defined gRPC interfaces to these rule providers, so it doesn't put any constraints or restrictions on what they do.
Yeah, but the enforcing happens at the network overlay, right? So it's up to the different networking overlays, right, to do the enforcing, right?
Yeah, we don't by default do anything to the network. We by default basically call out and say, okay, has this rule been violated? right?
I see.
Or is this, and in terms of scheduling, we say, can this rule be met? And we call out to the rule provider to make that decision. And so the rule provider makes the decision whether it can or not. We didn't want to bind this to any specific technology.
Got it. Got it. Okay. Thanks.
Yep. Any other questions before I move on? Okay. Move on to Pallet. So as we were developing Turnbuckle and we were creating constraints between workload sets, if you will, we came to the quick realization that there's a problem here. And what that means is we can't really optimize scheduling across inner workload constraints because workloads are being scheduled one workload at a time, i.e. the scheduler gets called, the workload scheduled, the next one gets called, the workload scheduled. And so as we get the multiple workloads being scheduled, we could use the constraint policy, but that didn't necessarily come up with an optimum layout of all these workloads across a cluster or across a multi-cluster. So to combat that, we thought, okay, what can we do and how can we do it within the context of Kubernetes so we don't, fork and really drive the schedule in a completely different direction, can kind of do it as an add-on. So we came up with Pallet. And what we did with Pallet is we came up with a concept of a pod set. And a pod set really is, again, using the same kind of methodology. It labels selection as much as possible. You define what we call a scheduled trigger. And that scheduled trigger uses labels to determine which pods are included in that trigger. And that then trigger has a state. And so that state could be it's pending. i.e. we're not scheduling anything in any pod that matches that label selection is not being scheduled yet. And what that does is the scheduler that we wrote basically looks for that and says, okay, if this pod comes to the scheduler and it's not the scheduler trigger to which it's associated by labels is not yet in a scheduled state, i.e. it's pending, we essentially don't schedule the pod, we drop it. And so the pod will stay in a pending state. And then when someone does a trigger, when that trigger changes from pending to schedule, then as the pods come through the scheduler, we will first call what we call a planner. Again, that's a gRPC interface located by a service lookup. And that planner will come up with essentially a mapping, an optimized layout of all the pods within that are associated with that trigger and which node they should be associated with. And then as the nodes come through the scheduler, if the plan exists, then we will use the plan to decide which node the pod should be on. If the plan does not exist, then of course we go off and create it and then pick it. We also have capabilities in there to say if the pod comes through a scheduler and it maps to a plan, but it's not actually in the plan, then we go recalculate the plan. And so the idea is to provide a mechanism through, again, gRPC extension through service lookup, the ability to optimize how pods are placed across my cluster or eventually across multiple clusters as a set, not as a one-to-one. And that's what Pallet does. Any questions on that?
So what is the use case together with Turnbuckle? So you have, I'm trying to make the connection between.
Yep.
Yeah. So, or an example or something that.
Right. So
that you
the thought was,
mm-hmm.
The thought was when you're doing inter-workload constraints and you're doing things across multi-cluster or even within a cluster, the optimum schedule and placement of workloads on nodes to meet those constraints can't always be accomplished one by one. And an example of that would be, it's possible if I have 3 nodes that I'm scheduled and they have constraints between them, that I schedule the first pod, and because there's no other pods available yet, that first pod is scheduled and it gets placed on a node. The second pod comes along and the constraints are evaluated, and that pod is placed on those constraints. But it's possible that second pod is placed in such a way that when the third pod comes along, the constraints cannot be met. Now, the thought would be, if instead we looked at all 3 pods as a set, we could come up with a placement of those pods on the existing nodes where all constraints could be met. So there are situations where simply placing a pod one by one, we believe, is not the best allocation of resources, is not possible all the time. Where if you allocate them by set or schedule them by set, you will be able to do so and do a better allocation of resources. And the planners that I talked about are, again, extensible, right? So any given company could write their own planner to optimize how they want to schedule a set of pods across their network based on the constraints. We have one that we use with constraint policy, but the pallet is not bound to constraint policy. You can use pallet regardless of constraint policy. So anybody could write their own planner to decide how best to schedule a set of pods on their system.
Got it. So what's an example? Like, for example, like if you have a constraint policy of latency that workloads need to service a request or need to receive a networking request with certain amount of latency, and how would you use Pallet for that? Like, you schedule more pods together or something, or?
Right. Again, with Pallet, what it allows you to do is say, look at all the latencies in this example, and look at all the latency between each node, and say, is there a mechanism or is there a plan that I can come up with which can place all the nodes and have all the constraints met?
I see.
Versus if I did it as one at a time, I may choose a node which then invalidates the placement of a node later on.
Okay. Got it. Great. Thanks.
Any other questions?
So yeah, just to clarify there, you're trying to place all 3 pods on the same node, or you just want all 3 scheduled and running at the same time because they're interdependent? Or maybe, I think it might be this third one, that you want all 3 scheduled to ensure that that node in fact had resources for all 3.
Well, again, yeah, they're not going to be placed on the same node. The idea is that across my cluster, or when we get there, across multiple clusters, that all 3 nodes are placed in a context. They know that the others exist, right? So they're placed as a set to optimally use your resources and allow the scheduling of the 3 nodes scheduling of the pods across multiple nodes. Whereas if I did it by one, if I schedule the second pod, I may put that pod on a node that then prevents the placement of the third pod because the constraints can't be met. That makes sense? The idea is, the real idea of Pallet is, we believe that there's some optimizations that can be made around resource allocation and pod placement when we look at pods as a group as opposed to pods one at a time. And that comes really into play when we bundle this Pallet with the Turnbuckle project, because we have inter-workload constraints.
Yeah, I think that cleared it up a little.
Okay.
David, I have one question. So you're saying pods as a group, can you hear me?
Yes.
Okay, sorry. I was just wondering. So my understanding is that when you have a deployment of stateful set, those are already grouping the pods, right?
When I do a deployment, those pods can be that can actually be deployed to any node, the pods within a deployment, right?
Yes.
They're not all necessarily going to be on the same node. So yes, when I'm working at pod, because that is a level of things that are scheduled. So if I create a deployment with 5 pods and with constraints between them, let's say I execute a Helm chart or a customize capability, which creates the manifest for the deployment as well as the manifest for the constraints between them. So I could then also, in terms of Pallet, specify a trigger for those pods so that they get scheduled together. Yes, the deployment specifies a group of pods, but in order to introduce triggers into a deployment, there's a couple different things, right? Do I do it as an annotation? And I'll be honest, annotations aren't my favorite thing, mostly because it becomes a schemaless capability, a schemaless thing.
Mm-hmm.
Also, it means that how would I do that when I want to do multiple deployments scheduled together, right? Maybe I'm using predefined Helm charts, and so I don't have control necessarily of what a deployment is. With Pallet the way it is, using labels, it's potentially that I can make sure that multiple deployments are scheduled together.
I see. Okay. And so this is mainly for ensuring, that those pods, underneath deployment stateful sets are grouped, and
Yeah.
put together. Okay.
And again, you can group them across those various higher level constructs, deployment set, replication sets, etc.
I see. Okay. And do you have the inverse? I don't know if this project would allow for that, right? Like, let's say you have a Cassandra database and a Redis database, but you don't want those to be running on the same node because they're both, going to use a lot of the resources. So,
again, in terms of Pallet just says schedule these together. So
Okay.
you could write your own planner that uses that. Our scheduler that does this isn't, we're trying to use the scheduler extension, right? So if I were to do that, I'd still use anti-affinity, right? We don't want to come up with a new capability. We want to add on to it. One thing that we've toyed with, and this is outside these projects, is how do we extend scheduler without writing new code or compiling a new scheduler, right? I want to be able to add new filter mechanisms or new, like the constraint policy scheduler without having to come up with my own scheduler. Right? I want to be able to dynamically add it. So we like this concept of being able to invoke a service, look up something by a service and call it and have that as an integration point. I understand there's drawbacks to it and scheduling, there's a lot of data back and forth, but it allows this dynamic capability, which I personally like. Yeah, I rambled a little bit. Okay.
No, it's fine, David. But thank you so much. I appreciate your what do you call it? Yeah, your responses to my questions.
Okay. Anything else?
So a follow up on that
Yep.
question. Sorry, we're asking a lot of questions, but like
no, that's good. Questions are good.
So this works together with either any of the other entities like deployments or stateful sets.
Yes.
So it doesn't have its own controller. Does it have its own controller? Like, because a replica set or deployments, they have their own.
We don't have our own controller for either well, for Turnbuckle, we have our own controller for the CRDs that we've added. And for Pallet, we have our own controller for the schedule trigger CRD. But in terms of the scheduling, we're just using scheduler plugins to extend it.
Okay.
All right. I jumped a little too far. So here's one of the early diagrams that we came up with as we were developing Turnbuckle. And what you can see is we created essentially telemetry collector pods on each node in our network. And I label this as future because in the current implementation of Turnbuckle, we haven't added the multi-cluster stuff because we need to get more involved with the multi-cluster SIG and work through it with them. We've done some internal work with multi-cluster. We just haven't put that in the real project yet. So we created all this, little sample pingers to go before this, just to collect telemetry, latency, and jitter between the nodes. I use this as a test case. And then once we had that telemetry, we were able to create constraints and policy rules based on that telemetry and use that to test the scheduler. We also looked at how do we bring in underlay telemetry, i.e. telemetry that, excuse me a moment. Pardon me, trying to get over a cold as well. We looked at underlay telemetry. How do we bring in telemetry that's not from a Kubernetes capability, right? So we have a metro to edge network. How do we bring in that telemetry? And again, because this is an extensible model and the rule providers are outside the core system, that can be done, right? Someone has to write it. Someone could write it and contribute it, but it has to be done. We've done some samples around that, and we're perfectly willing to put those in the project. We're just figuring out how best to put those in the project. So this is where this is kind of the test framework that we did, and then use that with the constraint policies or the constraint policies to schedule nodes. And again, because we think there's going to be more, I'll call it network diversity or network issues between multiple clusters and within a given cluster, we really believe as we get to multi-cluster support, that's where particularly the constraint policies around network issues are going to come into play, as well as the ability to modify the underlay, where that underlay could be modifying VPCs at any given hyperscaler as well.
What did, did you run a example of this environment, or this was like a test, and then what type of workload did you run?
A lot of, the workloads we were really doing were just kind of gRPC client server workloads at this point.
Okay.
Sample hello type programs.
Got it. Okay.
Just to really test out the constraints.
So it will be targeted for any type of workload, right? That maybe has a lot of interaction between the edge and a central location. Okay.
Correct. And we have plans or thoughts that, you could integrate this with NSM in terms of the underlay or network control, right? So that if you wanted to influence the network, you could use other CNCF projects like NSM to manage that.
Got it. Thanks.
Yep. So the underlay controller, which is really how do I modify the network based on need? Again, this was something that we played with. We did this on top of an open flow network using virtual switches, where we created a virtual network with latency that did not meet constraints. And then as we tried to deploy workloads that required higher, better constraints or better latency, we called out to the underlay controller, which we now call the network controller, and it updated the flow tables in the open flow network to create acceptable latency. So that's what we did as well. So we really think, again, as we go and bring this to multi-cluster, but potentially within a single cluster as well, the network controller, or really the constraint remediation controller, is going to become important, because the idea is if we can meet constraints, particularly once a constraint is, once a pod is placed or once a workload is placed, if the constraint is violated, it might be more efficient and cause less downtime to remediate via the network or via some other mechanism than to deschedule and reschedule the workload. And so particularly around network, it might be faster. Tearing down a workload, even a container, can be expensive, where a network update may resolve the constraint issue and not cause any downtime. And so that's kind of where that is going. We did well, essentially we had to come up with a patch on top of the descheduler, because the descheduler, to add new deschedule algorithms, is a code change and a recompile. So in the repository, there's a patch for the descheduler, for a version of the descheduler that the constraint Turnbuckle works with. And the idea here is Turnbuckle periodically evaluates the policies and rules, and if they're violated and the descheduler is running, we have policy in the descheduler configuration which says what to do. Policy such as ignore, i.e., okay, great, we'll report the violation, you'll be able to see it in the resource status, but we're not going to do anything. We also have the kind of remediation, go back to that constraint remediation controller, talk to it, see if it can fix it. And then of course we have the deschedule, which basically says when it's violated, just deschedule and reschedule onto a place where the constraint is valid. So we have integration with that project as well. These are the CRDs that we've developed and the relationships between them. Let you look at that at your leisure. So this is a little more interesting, where we talk about the actual CRDs and look at them. So here is a constraint policy, and you give it a name and a namespace. They are namespaced resources. You give it rules, and you give it a request and a limit. So here we kind of mimicked what we see with resources within the core itself, the core Kubernetes. Our request and limit, we don't constrain to an integer value. We fully believe that it will be a value plus a unit. So that's where that goes. And again, we then, here's an offer, which basically, if you look at it, we say targets can be one or more named or non-named if you want, label matches, right? So here in this example, we have a source and a destination. There is an implication here that when we call a rule, in this case, you can see the policy that the constraint offer is associated with. It can be associated with multiple policies as gold policy. So when we call that gold policy or the rules in that gold policy to get evaluated, we will pass the source and the destination pods that match. You'll see a binding gets created. And so in this case, the binding will be always, we'll have multiple bindings that are created out of this. And each binding will have one instance of source, one instance of destination. So there's kind of a implicit rule that the rule evaluation will understand how to deal with that, right? There is some implicit capability around that. You can see the violation policy is evict, which basically means when the policy is violated, we evict the pod and have it rescheduled. You can also see period and grace. And period essentially is how often should this policy be reevaluated. And here it's 5 seconds. And grace is essentially how long must this policy be violated or be outside the constraints limit value before we consider it violated. And the idea with grace is really that we expect, particularly around network, if I give it a 10 millisecond latency constraint or limit, every now and then that constraint will go above 10 milliseconds. But we don't want to consider everything. We don't want it to flap across the line, right? So we just got to give it a grace period to say if it's above the limit and it's above the limit, for this duration, then we need to consider an action. And so just to prevent lots of events when you don't really need them, when the system essentially can correct itself.
No.
What if you have an evict there and then you end up not satisfying the constraints, and so the pod will never get scheduled, basically? So on
yes.
Yeah, okay.
Yeah.
So you can okay, see.
So yeah, in this situation, we will try to do the remediation through the network controller first, but if we can't do that, yeah, then the evict. There's kind of an implicit always try to, if a network controller exists, and again, that's a service lookup, try it. If not, evict.
Are there any other mechanisms besides evict or maintain or something? Or
there's also
or
ignore,
and also alerting, maybe like you mentioned that you have telemetry data, right? So you could be alerted like if the constraint has been violated, right?
We don't have any alert built into it. It's a fine plan, right? As long as there's an alert channel, someone could be watching the status of the resource. So I can't remember if this deck has it. So every pair, the policy offer creates what we call a constraint policy binding, which is kind of the realization or the binding of a real pod to a real policy. And in that binding is the status of the rule evaluations as well as the status of the policy. So someone could watch, and we could create, we don't today, but we could create events that represent violation policy changes, right? Or I'm sorry, violation changes. And those could be used to alert. We don't do it today, but that's a perfectly reasonable extension or feature request.
Got it. Thanks. Yeah.
Just to clarify, so are you able to evaluate whether those requests and limit latencies are being hit via your telemetry pods? Is that what someone needs to add to their cluster in order to kind of evaluate that information, or how are you figuring out when latency requirements are being hit or not?
Okay. To reiterate, the latency and jitter were test rules, so they're not built into the system. So we do have samples that we used, right, with in the previous diagram where I showed pingers between them. So in this example, the rule evaluation for latency, when we're evaluating that policy, there is a service lookup for latency based on a well-defined label. And once that service is looked up, that rule evaluator will be called with the parameters saying what are the endpoints, or what are the targets, as well as what is the request and limit. It's up to that rule provider to determine if the rule is either compliant, it's at limit, which basically means it's not that the request, but it's within constraints, or it's violated. So if someone were to write a latency rule like we did, yeah, you would have to come up with a way to collect telemetry and a way to evaluate that telemetry. The test case we did was with a pod on each node that's doing pingers. And again, I don't think that's in the current Git repository that we've made as part of the sandbox proposal. It's perfectly reasonable to do that. I have no problem with that. It's meant to be an example, not meant to, again, Turnbuckle is all about, here's a framework to do this. We're not telling you what to do, because while we may care about latency and jitter, you may care about completely different things, and those rule providers and the telemetry to support those rule providers will have to be built.
That makes sense. Thanks for reiterating that. Come together with the pictures. Also, you said, okay, doing it with a pod that's running kind of as a daemon set is one option. What are some other options you can imagine for the same scenario of a latency rule? Are you saying like agents running locally on the nodes? Could you have something external of the whole cluster that's somehow measuring latency between nodes?
Absolutely. We fully expect that different people, if they were to deploy this, they might have different telemetry collection systems that they're using, right? Whether that's they're doing Prometheus, putting network data in Prometheus, or whether that's they bought a vendor solution that's collecting network information and they want to use that. And then all they have to do is write the rule providers that use that telemetry information, however it's collected, to evaluate if the constraints are being met. If people want to come up with rules and telemetry collectors that are, I'll call it vendor agnostic, and want to have that as part of the project, I think that makes sense. I kind of would probably push back at anyone that says, hey, I've got a solution for vendor X, whether that's us, Sienna, or anyone, right? Just because I'm trying to keep it vendor agnostic. But it's, as long as we're very clear that here's a contrib area, that would make, that could be a reasonable solution there as well.
That makes sense. Thanks.
Yep. So these next slides are really just kind of a walkthrough. We've really talked about this, and here you can see I'm actually using deployments. Deployments come through, the pod is scheduled because constraints are met. If they're not met, we can talk to the network controller to change the network constraints or change the network such that they are met, and then the pod gets scheduled. The second pod comes through. This is not using Pallet because we're scheduling one pod at a time, and the same process happens. This is an example of a kubectl Git for a binding, and here you can see for this binding, the gold buffer, it's in violation of the status, and it's got a reason. It's too slow, and so that can be then we can try to use the network controller to remediate that and get it back to a good state. And here you can see essentially it goes back and reprograms the network as an example. Pallet, we talked a little bit about this. I'm trying to see. I kind of walked through this at the introduction. It really is. We hold off scheduling pallets until the state of the trigger goes to schedule. And at that point, we call out to a planner via a service lookup, via labels, to come up with how we should plan those, or on which nodes we should put each pod. And then as each pod comes through the scheduler, we put it on the node to which it's been planned. Down here at the bottom, you kind of give a little workflow of what happens, right? If the trigger isn't scheduled and the plan is not created, we create the plan, and then schedule the current pod based on that plan. If the plan is created and the pod's not in the plan, we recreate the plan and schedule. If the plan is created and the pod's in the plan, we use the plan. That's just kind of the little logic flow we use as pods come through the scheduler. Planners, you can see, again, we do this. This is a common pattern in both projects. We look up things by well-known labels. And again, we're not bound to any given labels. We're perfectly willing to take the Sienna out of this, that type of thing. But allows you to create new planners without having to change code. Yeah, it's well-defined gRPC interfaces to call them planners. So we do have some marshaling back and forth to gRPC interfaces to deal with the planning, as well as to deal with the rule providers. I think that's about it. Any questions?
Is the project, or are these projects already in Sandbox? I didn't see that. I didn't see them.
They are not. They are not. They've been put on the queue for Sandbox evaluation. I think Turnbuckle is second in the queue, so I'm hoping I think the next meeting's in June, it gets put in. Pallet's 5 or 6 below that.
Got it. Okay.
One question I had here is, I think it would be interesting to see if there is anything related between this and node feature discovery, which does dynamic labeling of nodes based on their features. I could see there being some integration there with plugging in, kind of labeling the nodes with what kind of constraints, I might not be using the right terms, but what they meet, what requirements they meet, and integrating in that way too.
Absolutely, and we've actually we've got an internal product, well, piece of hardware, which is what do I want to call it? Allows you to schedule service functions, VNFs, and part of the node feature discovery is, hey, is this VNF aware, right, or VNF capable? And so yes, then those constraints can be part of that as well. So yeah, I would agree there is potential integration with the node feature discovery. And if someone can draw better icons, we're more than willing to accept them.
They look good.
Oh, excuse me.
So have you seen any type of applications where maybe some customers will run like some sort of constraints for, they want to run like something in a centralized location at the edge, and I mean, in some cases you have like this at the edge, this machine learning inference model,
Yep.
and then maybe they want to have some sort of constraints.
Yeah, we've seen, particularly at the edge, I mentioned service functions, right? Network service functions. So there are constraints between network service functions, with even just within a single cluster will come into play. If I have multiple compute capability down at the edge cloud, using constraints to help understand when I chain 2 service functions together, that the constraints can be met. That's one use case. Pardon me. We've also seen it in terms of going from edge to a more metro or upstream cloud, where there's an upstream service capability, and that needs to be within a constraint. And we've looked at, how does that play out in the mobile scenario, where you may be moving across multiple edges. And we've got some thoughts around that, nothing really solid yet, but there might be some work in there. But again, if I have an edge capability and my database is centralized, I may need a constraint, a latency constraint, or an error rate constraint, or even a security constraint around that capability. It's not all, while we developed this with kind of an eye towards networking, it's not required. So I could, as I said, have a security constraint between an edge cloud and a central cloud, which basically says only schedule these 2 pods such that the network between them meets some level of security. And then you could integrate that with a constraint remediation controller, which somehow sets up a tunnel to make that happen, or works with NSM to make that happen.
Got it. Got it. Yeah, I think the mobile use case is very interesting because I mean you have different types of behaviors depending on what so your cell phone, right? Like you're you maybe at a location where your network is not as good or you have more latency, or you may be connected to a node that is less secure or something like that. Yeah.
Yes. Yes.
All right. I think any last minute questions?
Well, if you come up with some later on, feel free to email me or Slack me, and be happy to answer whatever I can.
Yeah. I think some of us will be at KubeCon in a couple of weeks. So
Is that the European one?
yep. And,
Yep. I'm not going to be there, but enjoy KubeCon.
all right, thanks. So there's going to be a virtual broadcast, I think, if you want to watch some of the
I'll
sessions.
definitely attend the virtual one. We actually have proposed these two projects talks for KubeCon North America on these projects as well.
Awesome. Well, thank you, and looking forward to seeing the projects in the sandbox and maturing and growing and being more successful.
Thank you very much. Appreciate that.
All right. Thank you.
Thanks,
All
David.
right, bye.
Bye.
Thank you.
Bye.
Bye.